In this video, we're going to look at how to solve simultaneous equations using the substitution method. We're going to look at three types of examples. The first is using the y substitution. The second is using the x substitution. And the last one is an example where we have to rearrange the equation to make x or y the subject and then make the substitution. When solving simultaneous equations, we're often given a set of equations involving more than one variable. And the idea of the substitution method is that we want to substitute one of the variable and express it in terms of the other variable so that we're able to reduce those set of equations into one single equation with one variable which we're able to solve. So let's look at an example. Here I've got two equations, 2x plus y is equal to 9 and y is equal to 3x minus 1. Starting off by naming the equations 1 and 2, we see that in equation 2, we've got y is equal to 3x minus 1. So what we're going to do is we're going to replace the variable y with this expression 3x minus 1. So we say we're going to sub equation 2 into equation 1 so that we have 2x plus 3x minus 1 is equal to 9. This simplifies to 2x plus 3x minus 1 is 9, or 5x minus 1 is 9. We solve for x, we get 5x is 10, or x is equal to 2. Now, once we get the solution x is equal to 2, we're going to sub back into any one of the above equations. So in this case, I'm going to sub x back into equation 2. So we got y is equal to 3x minus 1. This is 3 times 2 minus 1, which simplifies to y is equal to 5. So our solution to this set of simultaneous equation is x is equal to 2 and y is equal to 5. And what this corresponds to is nothing more than the point of intersection of the two equations, which are represented by the two straight lines. When using the substitution method, it's not the case that we have to substitute the variable y and express it in terms of the variable x. We can also do the reverse, as I'll show in this next example. Here I've got my first equation, y minus 3x is 17. My second equation, x is equal to 2y minus 4. And what we're going to do is we're going to replace the variable x in the first equation with the expression 2y minus 4. So we say we're going to sub equation 2 into equation 1. So equation 1 now can be written as y minus 3 times, in bracket, 2y minus 4 is equal to 17. Now be careful with the next step, especially with expansion. We need to remember to multiply the negative 3 to every single term inside the bracket so that we get y minus 6y plus 12 is equal to 17. Negative 5y plus 12 is 17. Negative 5y is equal to 5, and therefore y is equal to negative 1. Once we've got the value for y, we then do the same. We simply take y is equal to negative 1 and sub back into any of the equation. So I'm going to sub back into the second equation. We then get x is equal to 2y minus 4, which becomes 2 times negative 1 minus 4, which will give us x is equal to negative 6. So the solution to this set of simultaneous equation is x is negative 6, y is equal to negative 1. And again, this corresponds to the point of intersection of the two lines. Sometimes we may not be given equations where x or y is the subject, so we need to rearrange the equation slightly prior to making the substitution. So next example, we've got 2x minus 3y is equal to 6 and 4x plus y is equal to negative 16. For this set of equations, I'm going to keep the first equation the same as 2x minus 3y is equal to 6. So this is equation 1. My second equation, I'm going to make y the subject. So we have y is equal to minus 4x minus 16. And I'm going to call this equation 2 dash. Same thing, we're going to replace the variable y with minus 4x minus 16. So we say we're going to sub equation 2 dash into equation 1. So we have 2x minus 3 in bracket minus 4x minus 16 is equal to 6. Again, we need to expand out the bracket. We're going to get 2x plus 12x plus 48 is equal to 6. 2x plus 12x is 14x plus 48 is equal to 6. So we get 14x is equal to minus 42, and therefore x is equal to negative 3. Once we get the solution for x, we again need to put back into any of the equations to solve for y, and for simplicity, I'm going to sub into equation 2 dash. So we have y is equal to minus 4x minus 16, which is equal to negative 4 times negative 3 minus 16, which is 12 minus 16. So therefore, y is equal to negative 4. So our solutions again are x is equal to negative 3 and y is equal to negative 4. Again, this is the point of intersection of the two lines. 4x plus y is equal to negative 16 and 2x minus 3y is equal to 6. Thanks everyone for watching the video. I hope you guys did find that helpful. Please help support us by clicking like and subscribe, and I'll see you guys all in the next one. Bye for now.